In this video, we're going to explore when variables are created, how long they exist in computer memory, and what happens when two variables have the same name in two different functions. Here we see function convert to minutes, which we explored in the function visualization lecture. We have added function convert to seconds, which converts a number of hours to an equivalent number of seconds. Convert to seconds does its work by calling convert to minutes and then multiplying the result by 60. Let's use the visualizer to explore this. We step over the two function definitions and notice that there are two function objects in the heap here. Also, convert to minutes refers to one of the functions, and convert to seconds refers to the other. Now we are about to execute an assignment statement. The right-hand side of the assignment statement is a function call, and so we evaluate the argument first. 2 will be created in computer memory over here in the heap, and we will get a frame for convert to seconds appearing on top of the stack. That frame will contain variable num_hours, which will refer to the value 2. We'll step forward to the first line in the body of the function. The first line in the body of convert to seconds is an assignment statement. We follow the same rules as always. We evaluate the right-hand side. That's a function call. In order to execute a function call, we evaluate the argument num_hours. That produces memory address x3. We send x3 into the parameter in convert to minutes, which also happens to be called num_hours. There are two variables called num_hours in the call stack. One of them is in function convert to minutes, and one of them is in function convert to seconds. Python keeps these two running functions in separate areas of memory so it does not get confused about which variable to use. We'll step forward to the body of this function. This is an assignment statement. On the right-hand side is an expression num_hours times 60. But which num_hours do we use? Python always uses the variable in the frame on top of the call stack. Variable minutes does not exist yet, and that's because the assignment statement hasn't finished executing, and we have not seen minutes before this. Once we evaluate 2 times 60 to get 120, minutes is going to be created in the frame on top of the call stack. That is always the rule. Variables are created in the frame on top of the call stack. Let's watch that happen. We're now about to return minutes, but where to? We have two possible locations. The answer is always to the frame just underneath the top of the call stack. This function call was paused right here on this call to convert to minutes. When we execute the return statement, we see that we're going to return 120 to whoever called this function. That happened down on this line as we explained, and so we're going to take the memory address of 120 and store it in a new variable minutes that is going to appear down here in function convert to seconds. This stack frame is about to disappear because that is one of the effects of a return statement. It erases the frame on top of the call stack, returning control to whoever called it. There it goes. Now variable minutes has been created. It refers to value 120, and we are about to execute another assignment statement. The right-hand side evaluates minutes times 60. Minutes refers to 120, so we end up with whatever 120 times 60 is, and variable seconds is going to be created and will refer to that new value. There we have it. Seconds stores memory address x5. At memory address x5 is the value 7,200. Continuing, we're going to return that value. That is going to return control back to line 20 here. We just are finishing up a call to convert to seconds. It produces the value 7,200, and we're going to create a variable seconds down in the main module that is going to refer to that value. Seconds now refers to 7,200. The frame for convert to seconds is no longer here. It's been erased. Just as convert to minutes was erased, when we executed its return statement.